All right, so we have inscribed angles. First, you have to know what an inscribed angle is. An inscribed angle is an angle whose vertex I'm supposed to say is on the circle, and the sides are chords. So here we have inscribed angle, angle C. It's an inscribed angle because the vertex is sitting on the circle, and it's made up of two chords. Chords connect pieces of the circle. So the endpoints, are all of the endpoints of the angle, lie on the circle. So that makes it an inscribed angle. And the arc, or the section of the circle that is between the endpoints of the angle, is the intercepted arc. It's an intercepted arc. We could call it arc BA or arc AB. Either way would be fine. But it's the arc in between the sides of the angle. All right, so having those definitions, we can look at the inscribed angle theorem that tells you that the measure of the angle, in this case angle B, the measure of angle B is half of the measure of arc AC. Or, if you have the angle and you're looking for the arc, you could say that the arc, the measure of the arc, is 2 times the measure of the angle. Which one you use depends on what you have given to start with. So I have some examples. It says find each measure. I'm looking for the measure of angle PRU. Here's P to R to U, so I'm looking for this angle right there. And I know that the angle is equal to 1/2 the value of the arc. Since I have the arc right there, it's 118 degrees, then the angle equals 1/2 of 118 degrees. So 118 divided by 2 tells us that the measure of angle PRU is 59 degrees. And the converse of that, looking for arc SP, we want the measure of arc SP. Well, here's arc SP. That's what we're looking for. We can see that we have the angle made up, the angle that makes that included arc. We'll call it angle R. No, SRP. Is 27 degrees. So 2 times the angle, which is 27, equals the arc. So 54 degrees. So one more of those. We have the measure of the arc, ADC. A, it's a major arc, A to D to C. So there's A, D, C. So we start at A and go all the way around. ADC, that's what we're looking for. The arc is equal to 2 times the included angle. So the angle, the included angle of that arc, is right here, angle CBA, or ABC, is 135 degrees. So 2 times 135 degrees is the measure of that major arc, which is 270 degrees. It's a big angle, or it's a big degree measure, but it makes sense because a major arc has to be greater than 180 degrees And looking at it, it's the majority of the circle, so that makes sense. And then the measure of angle DA. So here's D, here's E, and here's A. All right, so you can't see. Oh, DAE, D to A to E. I'm looking at this angle. And the measure of the angle is half of the measure of the arc. So the arc is between E and D. It's 76 degrees. So half of 76 is 38. So the measure of the angle DAE is 38 degrees. And next is corollaries. So that is the theorem, the inscribed angle theorem. The rest of this is corollaries. Corollaries are conclusions that you can draw based on the theorem. So kind of like a, oh, well, that makes sense kind of thing. So the corollaries, the first one is that two inscribed angles that intercept the same arc are equal or congruent. So in this case, if we wanted to find out the value of angle 1, the only thing on here is that 38 degrees. All right, so that if we have this angle is 38 degrees, and it makes an arc, it's an inscribed angle, so the measure of the arc is going to be 2 times the measure of the angle, and the angle is 38 degrees. So then we know that the arc has a measure of 76 degrees. So this arc has to be 76 degrees. And then we see that there is another angle made up with that included arc. It's right here. So angle 1 is half of 76 degrees. So that means that angle 1 must be 38 degrees. They must be the same. Because if I take the measure of angle 1 is half of the arc that's 76 degrees, then I know it's 38. So the measure of the arc is, in a way, measuring how open the angle is, like the degree of the opening of the angle. So if two angles open to the same measure, the angles must be the same size. Okay. There's another example of that to the right that we could do for extra practice, but I'm going to leave it. I think y'all get that, so I'm going to go ahead and go to the next corollary. It says that an inscribed angle in a semicircle is a right angle. An inscribed angle in a semicircle, because remember, a semicircle is an arc. An arc made up of a diameter. So in order to know that we have a semicircle here, you have to have a diameter. In order to claim that we have a diameter, the chord has to pass through the center of the circle, right? Or else it's just a chord. A diameter is a special chord that goes through the center. So the placement of that dot in the middle and the fact that the chord goes through it is what tells you that that is a diameter, and it gives you a semicircle. So that is pretty important. So the chord must pass, through the center to make a semicircle. All right, so that is a requirement. The chord must pass through the center dot. If it doesn't pass through the center dot, then it's not a diameter, so it's not a semicircle. All right, so we know a semicircle has a measure of 180 degrees. So then, using the inscribed angle theorem, that means that angle 2 is half, right? So the measure of angle 2 equals 1/2 of its intercepted arc, which is 180 degrees. And half of 180 degrees is 90 degrees, which is a right angle. So it's just a conclusion made based on the theorem. If your arc is 180, then your angle is 90. Okay, we could also use that in the example. First, make sure, yes, it is a semicircle because the chord passes through the center. So I see an angle and I see an arc. So the arc is over here on this side. Because it passes through the center, I know this arc is 180 degrees. And since the arc is 180, I know that the angle then is a right angle. So I have that angle Z, the measure of angle Z is 5A plus 20. And I can deduce that it is a right angle, so it's 90 degrees. So I could say that 5A plus 20 equals 90 degrees. And I could solve for A. I would subtract 20 and divide by 5 and get that A equals 16. 14, I'm sorry. A is 14. I'm not spending a lot of time on solving the problem, so you'll have time to work on your assignment. But if you wanted to work through it, you could. Okay, and then the last corollary that you can make is the opposite angles of a quadrilateral inscribed in a circle are supplementary. So remember, supplementary means adds to 180. So add to 180 degrees. Okay, so that means the opposite angles, when you have a quadrilateral inside the circle and it's inscribed, so the vertices of the angles are on the circle, the opposite angles are supplementary. So 1 and 3 are supplementary, and 4 and 2 are supplementary. I feel like this example gets a little confusing and misleading, so I'm going to leave that one at that and go on to the next one. I feel like the next one is a better example. The idea, I can still illustrate it there, that 1 and 3 are going to, I could write that. So angle 1 plus angle 3 is going to equal 180 degrees, and angle 4 plus angle 2 is going to equal 180 degrees. Okay, and then the rest of this, I'm going to do that example. It says find the value of D and the measure of angle JKG. All right, so the measure of angle JKG from J to K to G means I'm looking for this angle here. First, I have to find out what B is. So I have a quadrilateral, and it's inscribed in the circle. All 4 points are on the circle. Go ahead and notice that there is not a chord that passes through the center, so that there's no diameter, there's no semicircle. But I know that the opposite angles are going to be congruent. No, I'm sorry. The opposite angles are going to be supplementary. So that means that angle J and angle G added together is going to be 180 degrees. So angle J plus angle G equals 180 degrees. The opposite angles are supplementary. J is 6b plus 20, so 6b plus 20. Angle G is 3b plus 25, so 3b plus 25 equals 180. So then I'm going to combine like terms. I have 6 b's plus 3 more b's, means I have 9 b's. And then I have 20 plus 25. Those are like terms. So that's 45 equals 180. And now I can solve for b by subtracting the 45. So 9b equals 135 degrees. And if I divide it by, divide by 9, then b equals 15. All right, so there's part of my answer. B is 15. It says find the value of b and the measure of angle JKG. So angle JKG, if I take the b value and I plug it in, so now I take this b, I bring it up here to that b right there, I can plug it in. So JKG is 10 times the b value minus 69. B is 15. So all I have to do is calculate it. So JKG is 10 times 15, which is 150. Subtract the 69, and it gives me 81 degrees.